All right, now we're going to get into your chemical reactions and chemical equation labs. One of the first things we need to learn in this lab is how to balance a chemical equation. And we have to balance chemical equations because of the law of conservation of matter. So matter just can't be created or destroyed. It can be changed in a chemical reaction from one compound to another, or it can be changed in a physical reaction from like a solid to a liquid or a liquid to a gas. But the amount of matter stays constant because matter is made up of those atoms, and the atoms just change how they're arranged. Right. So if we look at a chemical equation like this, there's a couple new things that we might not have seen before. And it's these abbreviations here, and these are what are called the states of matter. So we can have something that is a solid, and that will be abbreviated with an S. We could have something be a liquid, and that will be abbreviated with an L. We can have something that is a gas, and that would be abbreviated with a G. And then we can have what's called aqueous. And that would be abbreviated with an AQ. And aqueous just means dissolved in water. So if you see AQ, whatever it is dissolved in a water solution. So let's look at how to balance a chemical equation. So what we see here is if we have sodium and we add some diatomic chlorine, we get sodium chloride. But if we look here, we have 2 chlorine atoms. Here we only have 1 chlorine atom. So somehow we've lost a chlorine atom. So we have to balance that equation so we have the same number and type of chlorine atoms on both sides of our equation. And the way I'm going to recommend that you do this is by taking count of all the atoms you're trying to balance and put an arrow or a line here representing your arrow, and then count how many sodium atoms you have on this side of the arrow. You have 1 sodium atom. How many chlorine atoms on this side? We have 1 chlorine. If we come to the other side of the arrow, we have 1 sodium. And remember, this subscript tells us 2 of whatever was before, so that tells us there are 2 chlorine. So we have an unbalanced equation. Unfortunately, there's not a lot of rules for balancing equations. What I'd tell you to do is start with the more complex compounds first and change numbers there, and leave things that are elemental to the end, because if you change the number of those, you're only changing one thing. And the way we balance an equation is by changing the number that goes in front. So right now, there's a 1 here saying 1 sodium chloride, 1 chlorine diatomic molecule, and 1 sodium atom. What we can do is change that number in front to add more of those compounds. And the other thing I would tell you about balancing equations, if you have an odd number on one side and an even number on the other, you have to make this side even, because you can never make an even into an odd number. So the first thing I would do is say, well, I have 2 chlorine here, 1 here, so I need to put a 2 here. So by putting a 2, that coefficient now says I have 2 sodium on this side and 2 chlorine. So now my chlorine are balanced, but now my sodium are unbalanced. So I have to come back to this side of my equation and change some kind of coefficient to balance out the equation. And I can see that if I put a coefficient of a 2 in front of this, now I have 2 sodium and I still have 2 chlorine. So now my equation is balanced. So that's how you go about balancing the equation. You just keep going back and forth until you to balance the equations out. The number and type of atoms has to be the same on both sides of the arrow. So on this side we have 2 sodium atoms. This side we have 2 sodium atoms. This side we have 2 chlorine and 2 chlorine. So we have the same number and type of atoms on both sides of our chemical equation. So let's look at another one we can try to balance here. If we have a water molecule and we break that apart into hydrogen, which is diatomic, and oxygen, which is diatomic, you can see we have an unbalanced equation because we have 2 hydrogen here, 2 here, 1 oxygen, but 2 oxygen. So we would start by saying we have hydrogen and oxygen we're trying to balance. On this side of our arrow, we have a subscript of 2, so we have 2 hydrogen in this water molecule and 1 oxygen atom. On this side, this diatomic hydrogen has 2 hydrogen atoms. This oxygen has 2 oxygen atoms. So you can see we're unbalanced, and also we have an odd number on this side and an even number on this side. So I'm going to try to make the coefficient over here even. So what I'm going to do first is try putting a 2 in front of the water. So that now we have 2 water molecules, so that makes 4 hydrogen atoms and 2 oxygen atoms. So our oxygen are balanced, but now we've unbalanced our hydrogen. So we have to come back to the other side of our arrow and say, well, we have 4 hydrogen atoms here, we only have 2 here. We're going to put a coefficient of a 2 in front of that. So now we have 4 hydrogen on that side, and we still only have 2 oxygen. So now we have a balanced equation in which we have 4 hydrogen atoms on this side of our arrow, 4 hydrogen atoms on the product side. We have 2 oxygen atoms on this side and 2 oxygen atoms on that side. So that's how we would approach balancing chemical equations. So that's one of the skills you're going to need to practice for this lab is writing these chemical equations and balancing them. The other thing that we're going to look at in this lab is what things indicate a chemical reaction has occurred, and one would be a color change. So if you mix some chemicals together and you see a color change, that's an indication that maybe you had a chemical reaction. Another would be that a solid forms. Right. So if you mix 2 liquids together and a precipitate or a solid falls out, that's an indication that maybe there was a chemical reaction. If we have a temperature change, right, if we mix 2 things together and the temperature goes up, that's an indication of chemical reaction that's exothermic happened. If it goes down, then we probably had an endothermic chemical reaction. And another thing we'd be looking for is bubbles forming, so formation of bubbles. That's usually an indication that you mix something together and a gas is formed, so you had a chemical reaction. So those are some of the indications of a chemical reaction. The other thing here that you're going to be expected to do is to classify the type of a chemical reaction. So one type of chemical reaction is a combination reaction. And here we're usually combining small molecules and making a larger molecule. So the general equation would be we're adding A plus B and we're making C. And an example of this would be our sodium plus our Cl2 going to form 2 NaCl, right? So we've combined 2 elemental things and made a compound out of it. So that would be a combination reaction. The kind of opposite of that is what's called a decomposition reaction. And in a decomposition reaction, you're taking something larger and making it into something smaller or more elemental. So if we took our water example that we just balanced, and we got 2 H2s plus O2, we're taking a water molecule and breaking it down into elemental hydrogen and oxygen. So kind of in general, this would be looked at as saying we have AB and it's going to A plus B. So that's what you're looking for, something larger breaking into something smaller. Right? And so instead of C there, we could have put AB there, I guess, and that probably would have made more sense. All right, so those are 2 types of chemical reactions you'll probably be seeing in this lab. Another type is called a single displacement. And that's when you have something, it's just single displacements. We have a right. So we have this guy that's by himself coming in and displacing this guy, and so now A displaces B, and A is now with C, and B is by itself. And then you also have what's called a double displacement. And that's where 2 people are switching partners. So if we had AB plus CD, now A is going to be partnered with D, and C is going to be partnered with D, so we'd have AD plus CB. Right. And an example. All right, so if we took zinc and added it to hydrochloric acid, we would expect that to form zinc chloride plus hydrogen gas. And so we balance our equation. So this is a single displacement where zinc is coming over here and displacing the hydrogen. The zinc is now with the chlorine and the hydrogen is by itself. So that would be a single displacement. If we had silver nitrate and added it to magnesium chloride, and it produced magnesium nitrate plus silver chloride, then we'd have a double displacement where this silver cation is now with this anion, right? So we have Ag plus here, and it is now with this Cl minus, and this magnesium is now with the nitrate, so the magnesium 2 plus is now with the NO3 minus. So the cation from this compound is with this anion, and this cation is with this anion, and that would be a double displacement reaction.